gamma spectrum that you get from fallout is different than what you get from prompt fission. Basically, the gamma ray distribution you would have in the core of a nuclear reactor, it does have some similarities with the gamma ray distribution you get from fallout. The big difference is the prompt fission gammas that you have in a nuclear reactor are not present in fallout. To make matters worse, the spectrum from fallout changes with time. Basically, as the radioactive decay takes place, the really short half-lived radioisotopes, they cease to exist, and they cease to keep giving off those same gamma rays, and so the gamma ray spectrum evolves with time from fallout as it moves away from a nuclear blast. To make matters even worse, the fallout is actually the particulate that forms and coalesces in the cloud and then falls out. So basically, if I have turned a bunch of sand into a gas, that gas will coalesce back into silicate and then fall out. And when that condensation takes place, it will carry with it a lot of the radioactivity. And the chemical composition of that initial fallout is going to be different than the fallout that you get further out. The stuff that's more volatile is going to coalesce with certain radionuclides at a different proportion than what you get with stuff that's less volatile. And so the evolution of the radioisotopes in the fallout changes as the cloud passes. The bigger stuff falls out first. It's got different chemistry than the stuff that transports further. And so it's a very complicated distribution. We know what it is pretty much more or less, and it's largely going to depend on the type of ground that took place, where the weapon took place, because that's what's going to loft into the air. When you volatilize that ground, that gives you a certain type of chemistry that's going to interact with the radioactivity in the mushroom cloud from a nuclear detonation. So that's a great question. Thanks for asking. I hope you enjoyed the answer and have a good day. Bye.